Welcome, everybody, and thank you for joining me today. My name is Colin, product marketer here at Premio, and we have an exciting topic for you all today, as we will cover one of Premio's most versatile edge computing solutions, our line of x86 semi-rugged industrial computers, also known as our BCO series. So for today's session, we'll walk you through what semi-rugged really means, how these systems are built for performance and reliability at the industrial edge, and where they fit within the broader edge continuum. We'll also take a closer look at each of the models, including our latest BCO 500 ADL, and show you how this system itself is helping manufacturers and system integrators accelerate their digital transformation. So whether you're modernizing a manufacturing process, deploying smart sensors, or building real-time monitoring systems, we hope this session will give you a deeper look into how semi-rugged edge computers can help transform your next digital application. So for this webinar, we'll start by defining what x86 semi-rugged industrial computers are and the role that they play in edge computing. Then we'll move into a high-level overview of the edge continuum and explain exactly where the BCO series fits within that spectrum. After that, we'll walk through the BCO product family, covering key use cases, performance tiers, and unique key features that are across the lineup. And we'll also compare the models side by side so you can see how they stack up. And finally, we'll introduce a helpful resource, Premio's Decision Toolkits, to support your hardware selection process and make your edge deployment easier and more efficient. So let's get started. So let's begin by answering a simple question. What exactly are semi-rugged industrial computers? In essence, they're compact, fanless, embedded systems designed to operate reliably in industrial environments that aren't necessarily extreme, but still require more durability than traditional commercial PCs. And unlike the fully rugged systems that are used in mobile and outdoor deployments, semi-rugged systems are intended for fixed installations such as control panels, factory floors, or industrial cabinets, places where there may be exposure to dust, vibration, and wide temperatures, but maintain an area activity where access and maintenance can be performed. These settings are typically found in areas where human personnel are close by and active and maybe on premises. And these controlled settings are what we define as industrial, don't require the full range of extreme ruggedization. Premio's BCO series is engineered precisely for this middle ground. It provides the performance, reliability, and industrial connectivity that modern applications demand, all while maintaining a smaller form factor and a low power envelope. So these systems are ideal for edge deployments where you need compute close to the source of data, but you don't want to over-engineer the solution with unnecessary ruggedization. So to better help us understand the value of the BCO series, let's take a quick step back and look at the concept of the edge continuum. Edge computing has emerged as a powerful alternative to centralized processing in the cloud. Traditionally, data generated by sensors, cameras, and machines were transmitted back to centralized servers for processing. However, that approach came with a lot of drawbacks. There was latency, bandwidth issues, and even security risks. And that's where edge computing comes in. So instead of sending all that data back and forth, we process it locally, right where it's being generated. And this allows for faster insights, real-time decision-making, and much more responsive systems. And for us at Premio, we focus specifically on what's known as the user edge, the layer of edge computing that sits closest to the point of data generation. However, the user edge is also a very large ecosystem that has vastly different and unique deployment requirements. And to better help us understand and segment these type of demands within the user edge, we break things down even further into three specific buckets: the industrial edge, the rugged edge, and the specialized edge. And starting with the industrial edge, this segment of the edge is focused on controlled environments, places like factory floors, industrial control panels, or even inside smart building systems. And these are deployments where conditions are stable enough that you don't need full ruggedization, but you still need reliable industrial-grade performance. And the key here is striking the right balance. Enough computing power to process data at the edge in real time, enough durability to handle continuous 24/7 operation, and enough flexibility to integrate with various systems, all without overbuilding for environments that don't require it. Next level is the rugged edge. This level of deployment is meant for harsher systems, places like remote field sites, mobile systems, or outdoor enclosures where conditions are far less predictable. We're talking about exposure to constant vibration, extreme temperature swings, and even unstable power sources. And in these kind of scenarios, the systems you deploy need to go beyond their basic durability. They need to deliver power efficiency, rugged reliability, and the kind of mission-critical performance that ensures everything keeps running no matter what the environment throws at it. And last but not least, there's a specialized edge. This segment includes highly regulated industries such as transportation, food and beverage, and pharmaceutical manufacturing, where compliance isn't just important, it's mandatory. Deployments in these environments require specific certifications or configurations to be considered. And we're talking standards such as EN 50155 for railway safety, IEC 62443-4-2 for industrial cybersecurity, or even IP69K rating for high-pressure washdown protection. And without these configurations or certifications in place, these systems simply cannot be deployed. It's all about meeting the strict regulatory requirements to ensure safety, security, and even sanitation. And that's where the specialized solutions come to play. And within all of these distinct segments of the edge continuum, the BCO series fits squarely into the industrial edge. It's purpose-built for environments that demand consistent uptime, compact form factors, and long-term durability, but don't necessarily require the extreme ruggedization. So now that we understand where the BCO series fits into the edge landscape, it's time to take a closer look into what makes these semi-rugged computers so effective. The BCO series is Premio's flagship line of x86 fanless embedded computers designed specifically for industrial edge applications. And these systems feature industrial-grade components, aluminum heatsink chassis for efficient thermal management, and wide voltage inputs for flexible deployments. So let's kick things off with the BCO 500, which serves as Premio's entry-level x86 industrial computer designed specifically for light-duty applications at the edge. At its core, the BCO 500 is processed by Intel's 12th generation Alder Lake N processors, its standard N97, which offers efficient quad-core performance, or an upgraded i3 N305, which provides additional processing power for slightly heavier workloads. And this flexibility allows you to tailor your performance to your exact application requirements. The BCO 500 also stands out for its ultra-slim form factor, making it a great fit for space-constrained installations, especially when compared to bulkier industrial PCs or consumer-based alternatives like Intel NUCs. And to ensure safe deployment in industrial settings, the BCO 500 has a unique UL 61010 certification that meets strict standards for electrical equipment that are used in measurement, control, and laboratory environments. So now let's take a look at the BCO 1000 series, which delivers a perfect balance between its features and affordability for industrial edge applications. And like its younger brother, the BCO 500, the BCO 1000 is also suited for industrial edge deployments. It offers enhanced connectivity, versatile storage, and cellular connectivity for those who require just a bit more. BCO 1000 also offers two different CPU options with its standard N97 and a much more powerful add-on processor, giving it a huge step up in performance. However, one of the biggest standout features when compared to the BCO 500 is its flexible storage options, with both M.2 and 2.5-inch SATA options on board, which make it easy to scale for data processing at the edge. So additionally, the system also features flexible I/O connectivity, which include up to 3 RJ45 LAN ports and supports 4G LTE and 5G, which make it perfect for deployments that require high-speed connectivity. Physically, the BCO 1000 does come in a larger form factor compared to the BCO 500 or other type of compact systems, but that added space allows for all the previously mentioned features to give the BCO 1000 a unique balance of industrial IoT features. And like all Premio systems, it's built for compliance and peace of mind. The BCO 1000 is UL, CE, and FCC certified, making it suitable for industrial and communication technology environments that require safe, long-life operation. So now let's move into the BCO 3000, which takes performance and flexibility to the next level in the BCO series. This model is designed for more compute-intensive edge workloads, especially repeatable tasks and automation. And what sets the BCO 3000 apart is its support for socketed Intel Core processors, giving you a wide range of CPU options to scale processing power based on your exact application needs. And it also strikes a smart balance between industrial I/O and form factor efficiency. Even with its enhanced compute capabilities, it maintains a small form factor chassis, allowing it to be installed in space-limited applications without sacrificing performance or any I/O accessibility. And just like the BCO 1000 and the BCO 500, the BCO 3000 also UL certified, CE, and FCC certified, ensuring compliance with safety standards for communication and technology systems in those industrial settings. At the top of the BCO lineup is the BCO 6000 series, designed for AI acceleration and high-performance edge computing workloads. This powerhouse system is built to support a discrete GPU, opening the door to more demanding compute tasks such as machine learning inferencing, advanced imaging, object detection, and real-time video analytics, all at the edge. And just like the BCO 3000, the BCO 6000 is powered by Intel Core processors, all designed within a slim, low-profile, short-depth chassis, making it easy to integrate into rack-mount systems or compact enclosures. Where the BCO 6000 really stands out is through its ability to allow for PCI expansion, integrate GPUs, or other high-speed expansion cards. While the high-speed I/O setup, including USB, COM, LAN, and DIO, ensures seamless communication with sensors, cameras, and other edge devices. And of course, the BCO 6000 is also fully certified for industrial use, meaning it's UL, FCC, and CE standards. So for organizations building edge computing that require GPU acceleration or imaging at the source, the BCO 6000 is the flagship model that delivers both performance and endurance in a compact industrial-grade package. So across all 4 available models of the BCO series, Premio has crafted each one of these to address the varying levels of operational demand and challenges found at the edge. And the series' common foundation lies in its commitment to its reliability, efficiency, and scalability, aligning closely with the needs of today's Industry 4.0. And now that we explored each of these BCO models individually, let's take a quick step back and look at the big picture. This comparison table here gives us a clear snapshot of how each model in the BCO series is designed to meet the different performance and application needs that we see at the industrial edge. And let's take a quick look at how each of these BCO models scales across each of these performance tiers. And we starting with the BCO 500, our entry-level model. It's ideal for those compact deployments such as IoT gateways, control panels, or even basic process control, giving you the fanless reliability, industrial certifications, and the support for wide power and temperature ranges, all within an ultra-compact footprint. And as you move up to the BCO 1000, it adds more flexibility with dual storage options and wireless connectivity, including 4G and 5G connectivity. It's a great fit for those connected edge computing devices and real-time telematic applications, while still maintaining that compact, semi-rugged design. And moving up to the BCO 3000, this introduces the support for socketed Intel Core processors, bringing that extra horsepower that's needed for advanced automation, data-heavy tasks, and multi-device coordinations. It offers richer I/O and is perfect for those smart factory deployments. At the very top of the lineup is our BCO 6000, that's built for AI workloads at the edge. It supports that PCI expansion for GPU integration, which make it the perfect and ideal solution for machine learning, vision systems, and high-performance inferencing in a slim, short-depth chassis. So we can see that each of these BCO models brings its own strengths to the table, which gives you the flexibility to match the right performance levels to your specific edge applications. So for those enterprise businesses planning to upgrade or expand their edge computing capabilities, the BCO series presents a wide range of options designed to enhance operational efficiency and harness the power of modern technology in Industry 4.0 settings. And we also understand that selecting the right edge computer isn't always the easiest choice, and sometimes it can be overwhelming. With so many models, features, requirements to consider, it's not always easy to know where to begin. And that's exactly why we created a helpful resource, Premio's Industrial Edge Decision Toolkits. These toolkits are designed to guide you through every key consideration before selecting a system, whether that's understanding your application's performance requirements, mapping up the right I/O and connectivity, assessing environmental constraints, or even planning for future scalability. Each toolkit is designed to include a practical checklist and a comparison table to help you evaluate your needs more easily and make faster, more confident decisions. And if your work focuses on specifically industrial automation or process control, one of our latest toolkits is made just for you, our decision toolkit for process control engineers. This version of the toolkit addresses the unique challenges and hardware needs involved in monitoring, managing, and optimizing process control environments at the edge. So whether you're an engineer, system integrator, or operations lead, these toolkits are here to help eliminate guesswork and reduce costly trial and error, so you can move forward with a solution that's built for your success. That brings us to the end of today's webinar. We've taken a closer look at Premio's BCO series, which is our lineup of x86 semi-rugged industrial computers built for performance, reliability, and flexibility at the industrial edge. From the compact and cost-effective BCO 500 to AI-ready BCO 6000, each system is purpose-built and engineered to help you meet the challenges of modern edge deployments, whether it's industrial automation, machine visioning, or AI inferencing. And if you're still deciding which BCO model is right for your needs, don't forget to download our free Industrial Edge Decision Toolkit. It's a step-by-step resource designed to help you evaluate your technical requirements and match them to the right industrial computing solution quickly and confidently. And if you have any further questions or you're ready to start a project with Premio, be sure to visit us online at premioinc.com to contact one of our embedded computing experts today.